Hi everyone, this is Mr. Cervone. Welcome to my math channel. In today's lesson, we will be learning about a special type of transformations, which is dilations. So here's the first problem. A transformation maps the point x, y to the point 2x, 2y. Find the images of point A, 1, 3, point B, 2, 5, and point C, 4, 4, under this transformation. So the first thing you want to do is plot the points and recognize that you end up with triangle ABC here. The next thing to do is to plot A prime, B prime, and C prime to obtain the following triangle. So what do you notice here? We notice that the triangle not only transformed upwards in a diagonal direction, but the triangle became bigger. So basically we have triangle ABC and you're multiplying the x and y coordinates by 2 to obtain a bigger triangle. And that is basically a dilation because we dilated the triangle to have a bigger triangle. Now in this particular case, if we, for example, connect point A prime to A and go backwards, and then do the same thing for B prime and B, connect those 2 points, and connect C prime to C, and then trace those points or create rays, so to speak, you actually end up at the origin, as you can see here. Now, why is that important? Because it turns out that when you define a dilation, you're actually not only dilating by a factor, but you're dilating by a factor over a point such as the origin in this case. So that brings me to the notation of dilation. So the notation is a capital D, and here we have a subscript, and in this case, let me insert the pen here. 1 second. There you go. So in this case, the subscript means 2 different things. That this one, the first one, is the origin, okay? So basically, that is the point of dilation. And then we have the K value, and the K value is the dilation factor. And there's much to be talked about the dilation factor, okay? So the question is, how does the K value affect dilation? For example, what if K is negative? Well, if it's positive, is there a difference between if K is a fraction or if K is an integer? So let's discuss this now. So let's discuss the following question for more definitive ways for the K value, okay? So here we have the dilation. Let's describe the image after the dilation for the following K values. For example, what happens when the K value is between 0 and 1? Well, you can expect here that the points will have a smaller coordinate, but not really 0, right? For example, let's say that the coordinates are 4, 8. Then if you dilate, let's say, these coordinates by a K value of 1/2, you end up with coordinates of 2, 4, okay? So if you do that for all the points, for example, if it's a triangle, then the figure is actually becoming smaller. It will shrink. So the mathematical term for that is called contraction. Now, what happens if the K value is 0? Again, if you multiply any number by 0, you end up with 0, 0 as your new coordinate point. So basically, the entire image will collapse into the origin, into one single point. So that's why we can say that the image collapses to the origin. Now, what if K is less than 0? Again, we can come up with an example. Let's say what we have a dilation over the origin, let's say of -2, okay? And let's call it points 3, 7. That's just an example. So we end up with -6 and -14, okay? So as you can see that the image became bigger, but it will be, it's kind of like a reflection over the origin. That's what's happening here, okay? So the image becomes bigger and is a reflection over the origin. So we can describe it as follows. So we have a reflection over the origin, okay? Independently if it gets bigger or smaller. But that's a different case that we can discuss in a few minutes. Now, what about if k is negative, just -1 and that's it? Well, in this case, we have a reflection over the origin, but no dilation at all. Keep in mind that in the previous case, when k is less than 0, we could either have a dilation or no dilation at all, depending on the value, okay? What if k is equal to 1? Well, in this case, the image is equal to the pre-image. And the reason is because there's no dilation and there's no reflection at all. And now the standard case, what if k is greater than 1? Well, in this case, the image becomes bigger, and therefore we just call it an expansion. Some books also just call it simply dilation, and that's it, okay? Okay, so let's summarize this. So in general, we can say that if the absolute value of k is greater than 1, then we have an expansion or a dilation. Basically, the image becomes bigger. And if the absolute value of k is less than 1, then the image contracts or it becomes smaller. As you can see that this case here, using the absolute values, that actually summarizes most of the scenarios that we had previously, okay? For example, that the k value can be greater than 1 or greater than -1 or less than -1, I should say here, which summarizes actually a reflection as well, okay? It includes the reflection when you use the absolute value of k. And when it's less than 1, it includes all the values between 0 and 1, okay, that are decimals or fractions, including the reflections, the negatives of those, okay? So let's look at an example now, how we can apply dilations to images. So the first example here says find the image of 0.3, 4 under the dilation of the origin by a k factor of -1. So the first thing you want to do is write it as the correct notation here. So we write dilation over the origin by -1 of 0.3, 4. And what we want to do here is just multiply each point by -1 to obtain -3 and -4. So in reality, we didn't really dilate the object or contract it, but in this case, we're just reflecting it over the origin. So this type of dilation is equivalent to a reflection over the origin. So for number 2, it says find the image of 3, -2 under the dilation of factor of 3 over the origin. So we write d sub 0, 3 of 0.3, -2. And now all we need to do is just multiply every point by 3. So here we end up with 9, -6, okay? So basically the point is being dilated, okay, over the origin. Now, for the third one, we have a combination of different transformations here, okay? So let me actually put everything on one line. There you go. So here first we have, let me ignore this. There you go. So first we have a dilation of the origin by -1/4, then we have a reflection, and then a transformation here, or a translation, okay? But we have two different points, okay? So let's write them out first. So we have the following. Okay, so then we read from right to left. So first we perform the dilation of 7, -4 over the origin by a k factor of -1/4. And now we get the following, that you end up with the image to be -7/4, 1. So now we're going to reflect that point over the y equal to x-axis. And as you remember, when you reflect a point over the y equal to x-axis, you swap the points, okay? X, y becomes y, x. Now all we need to do is translate that point by an amount of 1, -2. And we end up with 2, -15/4, okay? And finally, now we want to find the image of 1, -3 under that dilation, okay? But now the dilation, notice, is not over the origin, but is over some other point, 2, 4. by a scale factor of -7. How do we deal with this? Well, a few lessons ago in a YouTube video, I mentioned that when you transform a point over another point that is not at the origin, for example, a reflection or even a rotation, first you need to translate the point back to the origin, then perform the dilation as if it was over the origin, and then translate it back, okay? So let me write the equivalent steps here. So first, we translate the point 1, -3 by an amount of -2, -4, okay? So we bring that point back to the origin first. Now, we dilate that point, okay? And then translate it back. Now let's do that. So what do we get here? So if you do this here, okay, so we translate that point. So basically you do 1 minus -2, or 1 minus 2, I should say. Then you end up with -1, and then -3 minus 4 is -7, okay? So now we got it back to the origin, and we want to dilate that point by a factor of -7, okay? Followed by that translation here. So let me write that in because it's a compositions of transformations. Now, if you do this one here, now we multiply every point by -7. So we end up with 7, 49, okay? And we translate that point by 2, 4. 2, -4, I should say. Actually, it is 2, 4. Okay, so let me fix this here. It should be a 4 here. And that point becomes the following. 9, 53, okay? And that's basically the answer for number 4, okay? So I hope you enjoyed today's lesson. Again, if you have any questions, place a comment in the YouTube video here in the comment section. Otherwise, have a wonderful day.